So now we go to this example 1b. The question asks us to check whether these two lines are parallel or coincide, intersect or skew. So now we follow step by step. We start with the step number 1. Step number 1, we have to write equation in terms of symmetric form. Means right here we have our L1, the equation is x minus 2 divided by negative 4, which is equal to y minus 1 divided by 1 equal to z minus 1 over 2 divided by 5. And then for L2, we have here symmetric form of the equation x divided by 3, which is equal to y plus 2 divided by negative 1. And then equal to z minus 4 divided by negative. In this case, from here we can find its vector direction, which is given by, for the first L1 is negative 4, 1, 5. How do we know about this? You have to take this value. This is A, B, and C. And then for the second line, we have a vector direction 3, negative 1, negative 2. So now our second step, we need to check if we can write our direction vector of L1 and L2 in terms of negative 1, negative 4, 1, 5, which is equal to some value of t, 3, negative 1, negative 2. And then we can, if we can find the value of t that satisfies this equation, means that the equation may be parallel or coincide. But in this case, if you look at this vector, there is no kind of t that fulfill this equation. Because here, if I write negative 4 equal to 3t, I will got here t equal to negative 4 over 3. But when I substitute in the second terms here, the second terms here 1 equal to negative 1, this negative 1 times t. But here t should be equal to negative 1. So it is not equal. Means that here there is no value of t that satisfies this equation. Means that our line L1 and L2 is not parallel or coincide, but it is maybe skew or intersect. So now how can we check for this? We go to step number 3. For our step number 3, we know that L1 and L2 are intersect if there is point in which L1 and L2 are equal. So this L1 and L2 are equal if we can make both equations equal. So we know based on previous, we have L1 x equal to 2 minus 4t. Let's say this one I write as t1. And then I have y equal to 1 plus t2. And then we have z equal to 1 over 2 plus 5t1. Sorry, this one is t1. And then we have L2 x equal to 3t2. So now I denote for the second line t is t2. Y equal to negative 2 minus t2 and z equal to 4 minus t2. In this case, L1 and L2 are intersect if there is a point that made L1 equal to L2. Means that here L1 equal to L2, so here I have this x. I can make this equation of x for the first L1 equal to the second equation, the second line of L2 for x. So here I can write 2 minus 4t1 equal to 3, 2. And then if I write this equation in terms of 3t2 plus 4t1 equal to 2. For the second y, for this y, we have here 1 plus t1 equal to negative 2 minus t2. So we can write the second equation in terms of t1 plus 3t2 equal to negative 3. And for z, we have here 1 over 2 plus 5t1 equal to 4 minus t2 means that we can write the equation as that with 5t1 plus t2 equal to 7 over. So now we have three equations. Let's say this is our first equation, second and third equation. Now we solve 1 and 2 simultaneously. This is based on what you have learned before in secondary school, which is solving simultaneous equation. That is, let's say for the first and second equation, I can write here 1 for the first equation equal to 2 minus 3t2 divided by 4. And then I substitute this t1 in the second equation. I have for t1 here, this t1 I change with this. So I have for this one, 2 minus 3t2 divided by 4 plus 3t2 divided by negative 3. So based on this, I can solve it for t2. When I solve it, I can got t2 equal to negative 14. Once I got this t2, I can substitute in this equation, that is t1 equal to 2 minus 3 times negative 14 divided by 4. So when we solve this one, we got t1 equal to 11. So now we have t1 equal to 11 and t2 equal to negative 14. So we can use our last equation to check whether our t1 and t2 can satisfy equation number 3 or not. In this case, I substitute here 5, 11 for t1 plus negative 14. In this case, I got it is equal to 41, means that it is does not equal to 7 over 2. So that we can conclude L1 and L2 are skew. Means that here there is no T1 and T2 can fulfill all three equations. Well, means that there is no intersection point, so L1 and L2 are